Why I'm excited about being part of the GLOHRA network is because I think that the topic I've been investigating for the last 15 years or so is very much interlinked with these health aspects. And I also think that the health aspects of climate change could be one of the levers of how we can speed up the transformation to a climate neutral world. And I'd like to outline a few paths that I think will become more relevant now in the very next few years in our way to climate neutrality, and try to make the linkages to health here and there, but I'm well aware of that there will be better experts than me on these aspects in the audience, and I'm looking forward to learning from you during the discussion. So this, most of you will know to some extent. So this is a graphic that shows the linkages between greenhouse gas emissions, climate change, and health. And there's many different pathways. There's many different types of diseases or health impacts that are somehow influenced. On the one hand, we've got direct influence of climate change. For example, extreme events like the flooding in the Ahrtal will increase in frequency or intensity under future climate change. And of course, this directly affects lives because people get killed when the infrastructure goes away, when they drown, and so on. Also, pretty direct impact is heat waves, for example, a massive thing in the last in the last decade in Europe, for example, France and Germany, a lot of preempted lives taken through heat waves. And then there's also more indirect pathways. For example, greenhouse gas emissions goes in hand with air pollution because aerosols are emitted, and this has impacts on respiratory diseases. And also another indirect impact of climate change is via food production. Drought impairs food production in many parts of the world. Also, our agricultural system in Germany has suffered several times in the last decade. And then, of course, malnutrition and so on can harm people. In the end, there's more indirect effects like mass migration, violent conflicts, and so on that could all be enforced by climate change and impede on human health. Exposure to air pollution, for example, is estimated to cause 7 million deaths worldwide every year. And interestingly, if you calculate that in terms of costs, it would add up to 4% of GDP. And if you think of how much it would cost to transform the world in line with the Paris Agreement, which set out to limit global warming to 1.5 or 2 degrees, that would be only 1% of the global GDP. So it's clear stopping climate change is a good idea from many aspects. Health aspects are just one, but the question now is, how do we get there to limiting global warming? Well, we need to get climate neutral. More exactly, we need to get greenhouse gases to net zero. Let me show you what I mean. Here on this figure, we've got the most important greenhouse gas, CO2, shown on the y-axis. Shown are the annual emissions by humans in gigatons CO2 per year. So currently, we roughly emit 40 gigatons CO2 per year. And now, going forward, what we need, if we want to keep to the 2-degree target of the Paris Agreement, is to get the emissions down to zero early in the second half of this century. How do we get there? So this is the goal, or well, even for 1.5 degrees, we would need to have these zero emissions even earlier, around 2050. So within a few decades, we need to get CO2 emissions down to zero. The first thing that we need to do clearly is we need to be strong on emission reduction. We need to transform the energy system. We need to reduce demand to get a lot of emissions simply eliminated. But then after we've done that, we still have residual emissions. So we see there's emissions we cannot easily avoid, for example, from long haul air traffic, where we cannot use batteries currently. And the question is how we do that. Because after 2050, another reason for what I'm speaking about soon is after 2050, we need negative emissions. So there clearly we cannot just go by emission reduction, but we need to change the sign of our emissions. So this is a bit strange. The reason behind all that is we can apply technologies that get CO2 out of the atmosphere, that remove CO2 again from the atmosphere. And we seem to need them to compensate for the residual emissions, and some say also to ease our path there, but I would say strongly we need to reduce emissions in the first place and then can clean up the rest that we can't get there. And these negative emissions we need in the end of the 21st century, but we need them very soon already now, even though the net emissions may still be above zero, to compensate for that. We're just not fast enough with emission reduction. And how do we do that? Various methods we're going to speak about today. Afforestation, reforestation is mentioned here. There's all kinds of so-called negative emission technologies or carbon dioxide removal, NETs or CDR abbreviated. And I'd like to point out that this reaching climate neutrality is very important on the land use side, because a lot of hope is put on land use to get these negative emissions delivered. Here's one study that estimates how much the land sector can really deliver. Here's shown for the middle of the century. 8 priority land-based measures are mentioned here. So this is, again, the business as usual scenario of emissions. This is how we need to get down to 1.5 degrees, and this is what the land sector could deliver. And it's estimated that about 30% of the total mitigation needed could be delivered by the land sector. There's 2 parts to it. The one could be emission reduction. We reduce deforestation. We change our diet. We reduce food waste. This is still on the positive side of emissions, but on the negative side of emissions, below the zero line, there would be carbon dioxide removal, soil carbon sequestration, forest management, restoration of forests. We speak about that in more detail. So a heavy burden, much hope put on the land use sector. And this is an incredible request to the land sector, given what we already request from it in terms of delivering food and fiber to an ever growing and ever more affluent population. So I'd like to take one step back and dive deeper down in history to understand what feat it is that we're facing. So agriculture per se has started around 10,000 years ago in several parts of the world. Independently, domestication happened over the subsequent millennia. And from there, agriculture spread to reach a lot of regions of the world. I'll just show you the spread of cropland here for the last millennium to give you a feeling for how quickly things have accelerated. We are here now deep in medieval times, and you see China, India, Europe popping up with agriculture being prominent there already. The scale shows you the fraction of each grid cell covered by cropland. And then now moving through history. In general, of course, population grows globally, and this means people need more land for growing food. But also some interesting things happen. For example, look into Europe now. Here you see how agriculture suddenly goes back because Black Death arrives, kills 1/3 of the population. We see something similar happening here with the fall of the Ming Dynasty now in China. We see how people spread into the North American continent, or then across the Urals into Central Asia. And finally, we're in the future scenario where most of the deforestation will happen in the tropical regions. So almost all of the ice-free land surface has been touched by humans via land use. To be more accurate, it's 3/4 of the ice-free land surface that has been used. A lot is land cover change, so we really clear forests to put cropland or pastures there. But a lot of it is land management, where we think we're being more subtle. We keep the forest, we just manage it, we just harvest the part of the trees, or we keep the grassland, but we put cows on it. But scientists have found out that this land management just seems to be subtle because you don't see it so clearly in the landscape, but it has effects on climate that are equally large as that of really deforestation per se. So this is interesting. Just 1/4 of the ice-free land surface is still wild. And the effects on the ecosystem are striking. This is a study we performed where we tried to estimate how much biomass is lost by land use. And we found that globally, half of the vegetation biomass has been removed by humans through land use. When you look into certain regions and you look in the scale, you see that in some regions, almost 100% of the biomass has been destroyed. Forests has been cleared for agricultural land. So this is the historical extent of land use. Now let's go into what this causes for climate. Well, the most striking effect is via greenhouse gas emissions. Each year, as part of the Global Carbon Project, we try to estimate how much humans emit in terms of CO2. Land use is one part. Fossil fuel emissions is the bigger part, of course. And overall, we approximately emit about 40 gigatons of CO2 each year. We found that in 2021, the emissions had already recovered from the pandemic to reach almost the level of prior to the pandemic. If we continue to emit at current rates, and if you want to keep the Paris Agreement of 1.5 degrees, we could only emit 11 more years and then needed to be at zero emissions directly. So fossil fuels emissions, as I said, is the prime cause for climate change, but let's go to the land use, which is what's interesting us and where a lot of the future dynamics will happen. Here I show you the land use emissions. The black line is always the same in all the plots since 1960, and they're split by region here. You see there's also negative emissions here. For example, in shifting cultivation, you do have reforestation all the time, but you also have clearing for agriculture of the forest causing emissions. And in particular, the tropical regions take a large burden of emissions. So you see here all the three continents in the tropics. This is where currently most of the deforestation happens. And it's carbon-rich, pristine rainforest. And we're going in there a lot for export. Export where? Well, to Europe or China of soybean, for example. Let's look here into gases. CO2 is the major greenhouse gas, but also methane from ruminants, from wet rice, agriculture is massive, and N2O occurs whenever we use fertilizers. Let's look at the product groups. If you split emissions by products, regrowing forests cannot be attributed to any product, but the positive emissions can. Cereals, of course, we eat a lot of cereals, and there's high emissions in there. But then also beef is big. If you compare that to the overall net emissions, the black line, we find that about 25% of the global land use emissions is caused by beef. But beef just delivers 1% of the calories that are consumed globally. Other interesting facts are that overall, these emissions make up 25% of the total anthropogenic emissions of all three greenhouse gases mentioned here. So land use is a big thing. It's not just the fossil fuels. And also emissions have not yet started to decrease. At least there's no robust sign of that, although we are 6 years after the Paris Agreement. Now let's turn this a bit around. What else is there to say about emissions from land use, and then the possibility of side effects via changing diets because we want to reach the Paris Agreement. So coming back to our question in the very beginning, obviously one lever to limit climate change would be to switch diets. If we can eliminate our consumption of beef, we would have 1/4 of land use emissions eliminated. And so this could be something that has direct impacts via greenhouse gases on climate change. But there's also other effects of the changing diets, not just on climate, but also on the ecosystems. If you look into the agricultural land use globally, you find that we have about twice as much pastures as compared to croplands. And the pastures, many of those are used for beef production. And so approximately, just very roughly, half of all the land use could be eliminated if we didn't rely on beef so much. And then health aspects. There's a study here by Hamilton that estimates that millions of deaths could be avoided worldwide. Well, they investigate that for 9 specific countries, and that's then 7 million people whose lives could be, whose deaths could be avoided if we change to a more healthy diet. The changes in dietary risk, the one aspect, but then also that obesity is reduced or under or overweight is reduced plays in there. In Germany, the number they give is 188 per 100,000 people in 2040. So this is where I then calculated it should be approximately 150,000 lives avoided or lives saved in Germany alone by changing to a diet that eliminates or reduces greenhouse gas emissions in line with the Paris Agreement. So 150,000 deaths, you tell me how much other diseases cost. It's similar to the number of COVID deaths we've had so far in Germany. So clearly we've got bigger problems in the pandemic times currently, but soon again, I guess climate change will be on top of our daily agenda again, and then we need to find solutions. And these solutions could be in the land use sector. First, because we can reduce emissions greatly here, changing diets, reducing food waste, and so on. But then think of the other side of the figure where I showed you that 30% of the mitigation potential lies in land use. We could actively draw down CO2 from the atmosphere. And this is where we come to the carbon dioxide removal. And I'd like to introduce you to some of the key methods that are being discussed there. Some you've certainly heard of, others may be more exotic, and all are interesting because none of them is, I think, the final solution. Each one of the methods I'll show you has some advantages that I mark here in green and has some disadvantages or risks that are marked in orange. The figure I put here in the middle from a review of carbon dioxide removal methods from Jan Ning, Sabine Fuß, and others, they show you these methods sorted by the potential of carbon dioxide removal given here in gigatons CO2 per year and the costs in US dollars per ton CO2 removed. Again, currently we're emitting about 40 gigatons of CO2 per year. This is the potential in the middle of the century that they estimate. So you already see, to take that up front, none of these methods could ever alleviate the need for massive emission reduction. None of these methods gets up to 40 gigatons of CO2 removal. But these methods could be used to compensate for the non-avoidable emissions like long-haul traffic or methane and N2O emissions from agriculture. Method number 1 is depicted here, afforestation or reforestation. Obviously, there's a lot of CO2 stored in the stems of the forest, thus it's removed from the atmosphere, and possibly you use it in long-lived products afterwards. That would be perfect. It's cheap. Regrowing a forest doesn't cost you a thing, and it's ready. We've done that since medieval times, heavily reforesting the landscape in Europe. But a forest behaves differently from a cropland, so you will inevitably alter water and energy fluxes, often to the beneficial terms. So in many studies, we could show that you could cool down the local climate by several degrees, possibly alleviating the heat stress on people living there. But it could also go a wrong way. So we need to be really careful, need a lot of research there. Permanence is another issue. Just think of the droughts we've had in Germany in the last decade. The forest was stressed, a lot of trees died, and then of course the CO2 would come out again. Let's move to biochar. What's that? Well, you use biomass from leftover residues on the field, or you grow biomass on purpose, and then you burn it, so you do pyrolysis on it. It gets inert. The biomass gets transformed into inert carbon compounds, which you can then take out to the field or whatever. It's just sitting there. The nice aspect is it may increase soil fertility, water availability to plants, or nutrient conditions could be improved in the soils by adding biochar. But you need a lot of biomass to get big potentials, and this means there's a limited potential because you're running into trade-offs with food production and the afforestation, for example. Bioenergy with CCS, that means carbon capture and storage. This is a miscanthus plantation. These are medium-sized colleagues of mine, and you see it's massive, it's tall grass, super dense, a lot of biomass being grown there, which you could use for pyrolysis, for biochar production, but you could also burn it directly to produce energy. And then if you take out the CO2 in the chimney of your plant, and then take that CO2 and put it somewhere in long-lived reservoirs, geological reservoirs, or certain products and so on. So do this CCS, it would become a negative emission technology. The question is, can we scale it up quickly? Do we have enough land? And then, that's my personal opinion, it could be ugly. A biodiverse forest certainly would look nicer than this biomass plantation. And another method here, enhanced weathering. That's interesting. If we grind up rock material, you get fresh surfaces of this rock, and this can weather. weathering of rock basically just means that it takes up CO2 and transforms its minerals. It's pretty permanent. The CO2 can't come out again. It's what nature does on geological timescales for billions of years. Here, we think we can accelerate that process by really grinding a lot of material up finely. It could have similar effects as the biochar in terms of soil fertility improvement, but just think of the ecological impacts of mineral extraction and transport. If you wanted to compensate for current emissions, you needed to grind up about 2 times the Matterhorn each year. So that's crazy amounts and big impacts with all the infrastructure behind it. And then soil carbon sequestration, leaving the residues on the field could be nice. It doesn't only add more carbon to the soil because you're removing less of the biomass, but it could also help against erosion, for example, enhance productivity of the plants, therefore. But there's also limited potential of how much you can really put into the of the CO2 into the soil. So there's no silver bullet, but there's a lot of options that could have benefits in other aspects that we should explore and definitely try to seek while we try to avoid the risks and the detrimental side effects that could come along with it. We probably need to have a portfolio of different options because none of them has a substantial potential in itself. And we try to distribute risks. Therefore, portfolio assessment is usually a good idea. But again, it's not adding up to alleviate our need to strongly and quickly reduce emissions. And there's a lot of trade-offs of all these carbon dioxide removals with other ecosystem services. But these trade-offs could potentially also lead to synergies. These win-win situations are also partly outlined on the previous slide. So these are, again, CDR options that are being explored: biomass plantations, afforestation, or agroforestry, something we haven't spoken about. And these are ecosystem services in general. So you see regulating ones like purifying water or regulating air pollution. Cultural tourism depends on the nice ecosystems, provisioning of food and fiber, supporting biodiversity, and so on. And we must never forget that there's a lot of different dimensions, different types of ecosystem services that are being delivered that are important to us and other animals and plants. And so we should really be aware of massive trade-offs that may happen, but also the synergies that could be sought. So just think of, could you send tourists into this afforestation, or could you instead think of maybe a biodiverse forest that then also fulfills these aspects of biodiversity, higher photosynthesis, for example. Agroforestry seems to be a wise idea because you both fulfill the need for food and fiber for production, but also have CO2 stored in the trees. It could also be a good idea because the trees make the local climate more regular, more even, so less heat events, for example, in the understory. So therefore, the food production could be more permanent. So there's a lot of beneficial side effects that really need to be explored now that land use is under such big additional pressure. And another way to depict these synergies is on this famous cartoon that some of you may have seen. It's a scene where a speaker is at one of these climate conferences, a climate summit, and speaks about all these positive side effects climate protection in general, not via terrestrial carbon dioxide removal, would have, like energy independence, green jobs, clean water, healthy children, and so on. And then this guy in the back asks, but what if it's a big hoax and we create a better world for nothing? I think if we take care of that, all these climate protection measures deliver these other synergies for other dimensions, then we're on a pretty safe side that we're also doing something good, for example, and this is why I like the slide too in this context here today, for health aspects. So this is what I would like to discuss with you after your short break. I was asked to put in one other slide, and Esther, is this the time where you want me to show it and discuss it?
Yes, please.
So you asked me what global health research is to me. And as I said, I'm someone very far from this field, but with a very strong interest for good reasons. And one reason is that I think global health research is really an interdisciplinary field. these many dimensions I showed for the ecosystem services of, for example, outline that I think these all need to be integrated and then could help improve health across scales for individuals, for societies, but also then globally and not just for individual countries. It could be a transdisciplinary field. I think science communication is also a very important part here. And I also think global health research is opening paths for a holistic view on the interactions of humans and the natural Earth system. We're not just speaking about global health, we're often speaking about planetary health in my field too, where we think that, that really the individual health is closely related to the health of the ecosystems of the planet. And there, I think what I outlined with land use is making that point very clear. So thanks very much for listening to me.